Hey, welcome back to science. If you were in class today, you would be greeted when you came in with this contraption. Let me see if I can flip this around. It is something that is borrowed. I will fill you in later who it is borrowed from. As you take a look at this, you'll notice this part that is cut away. That is not normally there. That is cut away so that you can see the insides of this thing. You can even look in from the top and it looks something like that. It's got a lot of holes. There's a tube up top. There is another tube here and then a tube on the bottom. So that is our question. What the heck is this thing? When we've done this in class before, the comments that people come up with are pretty amusing. Among them are, it's a jet engine, it's a cappuccino maker, it's a hot chocolate machine. Those are my favorites. I can't remember some of the others. What do you think it is? Okay, our topic today is home heating systems. That might give you a little bit of a hint as to what our mystery device is. We'll get there. I'm a little bit bummed because you'd be able to ask tons of questions if we were here in class. If you have those questions, save them up. Feel free to ask them. I'll do my best to try and hit commonly asked questions. So it comes down to, basically there are three real common conventional heating systems. Something called forced air, something called hot water, and there's something, for lack of a better terminology, an electrical radiator, basically using electricity to heat the home. You probably have one of these three methods in your house right now, or apartment, or wherever you are living. The fuel for all of these, for the forced air or the hot water, does vary from house to house. Among the possibilities that you may have: wood, natural gas, propane, fuel oil is even a possibility. I'm sure there are others. We're going to take a look at each one of these a little bit more in depth here. The assignment at the end of the week is going to be taking a look at what you have in your own house, so keep that in mind while we go through these. Okay, so a forced air. Basic idea here is you've got a box with a fire in it. It's a metal box. The box itself is not going to catch on fire. It's vented to the outside. The high efficiency ones vent usually straight out the side of the house. This one is showing something venting out the top. Then you have a box around that box that has the fire in it, the combustion taking place in it. The air in this secondary box warms up a lot, and then that gets pushed around the entire house. I love this graphic because it's really, really simple. There's also a couple problems with this graphic. Who puts a fan right there? That's a really bizarre place to put a fan. Plus the filters, I have never seen filters set up over there. You say, hey, why would there need to be a filter? Well, we're moving all this air around. We're pushing hot air out. We're bringing colder air back. You want to be able to filter that air a little bit. We'll hit that in a little bit as well. So while this is a great basic idea, a little bit better version of it may look like this. This is a real traditional looking furnace. You'll notice the chemical reaction is happening right here. The furnace fan is right underneath it, and that pushes the air up to the house. And you have a furnace filter. If this is what you have, find where this is and find out what kind of filter you have. This is one style of furnace filter, one size. They come in all sorts of different sizes. It's to your benefit to know what kind of furnace filter, what size you need, and how to install it, how to take out the old ones. They usually will have a little arrow on them saying, hey, this is the direction of airflow. You'll want to pay attention to that. When we take a look at how this is set up in the whole house, you have some registers that are warm air. The warm air is coming out there. And then you have some that are cold air return. I remember having somebody say, hey, I found a register in my house, but there's no warm air coming out of it. Could it possibly be the cold air return? That certainly works. Often, not always, often the cold air returns are more toward the center of the house, and the warm air are more toward the edge of the house. Typically, these are closer to the floor in both cases. Not always. In fact, in this classroom, they are all in the ceiling. An unfortunate way to do it, but a lot easier to go through there than to try and go where there is no basement or crawl space. Forced air is kind of cool. Some of them use the fan to blow air around. This is a really ancient, old-looking one. I think this might be from the house that I lived in college when I was off campus. Some of them even use what's called a gravity feed. They simply use convective currents to heat the house. Warm air rises and goes up. If you have been in a house where there is some vents, some big gaps, usually slotted so that things don't fall through between the floors, congratulations. That's a house that is using gravity feed. It's counting on convective currents. If you want to keep the upstairs cold, block those vents, close them up. If you want to allow warm air up, by all means do that. There always has to be a way for the cold air to come back as well, for the cold air return. Okay, moving on to hot water heating. It's basically the same thing. You got a box where there's a fire, something's being reacted, natural gas, propane, fuel oil, wood, and that box with the fire in it is warming up a box that's next to it that has water in it. I say box, but that's really a little bit misleading because this is actually a boiler. This is courtesy of Air Care. I have this very type in my house. They were really nice to let me borrow this. And again, it doesn't normally have this cutout in it. This is so you can see what's going on inside. Inside, we have a tube for cold air to be coming in, cold water to be coming in. That water rushes up past all these tubes, goes through here, and then it comes out through this. It's being pumped out to the rest of the house. And you say, well, what's going on in all these tubes? Well, there's a chemical reaction taking place. That chemical reaction, think a big flame is going on. Well, then you say, well, what's the point of having all these little tiny cylinders in there? Come on, you guys know this. Why would they have all these little cylinders instead of just one big tube? That's right, it's increasing the surface area. More surface area means that the water is heated up by conduction even faster. It's more efficient at transferring its thermal energy to that water that is going past. We can see that the hot water also vents to the outside. Again, it can go out the side if it's high efficiency or out through the top. This is interesting. There is an expansion tank. You need to have that because the warm water, or the water being warmed up, will expand some. So you need to have this expansion tank to keep from bursting pipes. So here's what this system looks like in a house. This is the one from Air Care. That's all you see. I actually really like the system because it also ends up heating the water. So this same flame, this same boiler, will heat the water for showers as well as heat the water that's going into the floors, basically. It's an in-floor heating system. So here's the old style of radiators. If you have these, cool, you live in one of the classic houses around here. Well, my question is, hey, what method is this using to heat up the air right next to it? Well, the air right next to it, that's by conduction. But then that air that is warmed up starts circulating by those convective currents. So we have convective currents happening. And hey, here's that question again. Why is it designed with all this area? Why not just have one big hot pipe going through there? Well, stop me if you've heard this before. Lots of surface area. That's the whole point. Lots of surface area again. It's important to note that this is not the only way that you can use hot water in your home. Many of you may have some other methods. In floor is kind of cool. There's even sometimes they use in wall. In floor is very common. Another one, if you have something that looks like this in your home, it very likely is hot water. Be careful. The electrical also does look like this. So Air Care also let me borrow an example of this. We can pull it out and you can see that again it's using all the stuff we've been talking about in science. Hot water goes through this tube. By conduction, each one of these little fins is getting warmed up and you have all that surface area so that air goes by this, warms up, convects out. Now, some of you, you know who you are, throw things down on the floor and block the bottom of this register, of this radiator. If you do that, shame on you. Why is that a problem? No, it's not going to start a fire. Come on, this water is at most 100 degrees Celsius. You're not going to start a fire with that. However, you're stopping the convective currents from happening. Cold air has to be coming in through there. You have to have access to air coming in this way. Quick thing that I'm going to take a note with, if you have this in your home, take a peek in there. If it's loaded up with dust bunnies, then it's time for you to, with your parents' permission, get access to this. These parts, this part comes off, and when this is still in situ, get yourself a vacuum cleaner with a brush attachment and just vacuum that off. Be careful, these things can be really sharp and you don't want to dent them and bang them. You can see this display model has had that happen quite a bit. You want to minimize that. But getting those dust bunnies out of there will make your system, make your radiator a little bit more efficient. It's worthwhile doing. Again, check with your parents. Okay, here's our moment of moving on. So electrical systems, it's not really a lot to say. Some people will have these in a small area. Bathrooms are real common. They'll put it under the floor and then they have a timer set so that a little bit before they wake up, it warms up the floor in the bathroom so that people can step in there barefoot and not jump out of their skin. The radiators that are this style, it could be electrical as well. They look really similar. I'm not certain how to tell the difference just by looking at that. So for all of these, for everything, yin and yang, there's drawbacks and benefits for everything. Going over them relatively quickly. These are just my opinions here. For forced air, a drawback is, according to some people that have lived in this, it pushes a lot of dust around. If you have forced air, you probably know whenever the furnace turns on because they're kind of loud. You can hear all that air moving. But there are some benefits. It's relatively easy to install, relatively inexpensive. I guess a secondary drawback is that the ductwork is rather large. If you go into your basement or crawl space and you see large chunks of ductwork, both rectangular and circular, that is probably air ducts for your furnace. One of the best things about it is, I checked with Air Care. In their history, no one ever has called them panicked in the middle of the night saying, dude, we've got a leak in our air duct. There's hot air spilling all over the basement. You gotta get here. Never happened. And it won't happen. In fact, literally, that's why they call it duct tape, even though it's not the best thing to use. It's duct tape, not duck as in quack quack. That is a brand name because people didn't know how to spell it properly. Duct, D-U-C-T. Moving on. Hot water. Bias alert, my personal favorite. The piping for it, it's a drawback because you have to use a lot more piping because you can't just dump the hot water into a room and collect it somewhere else. You have to have it contained the entire time. The other drawback to that is if it were to leak. This is rare, but if it were to leak, well, water uncontained in a house is rarely a good thing. So except think about the few places that you have water loose in the house, there's always a drain right there. Water getting it back in behind walls, not going to be good. Very efficient, very quiet, my personal favorite. And then there's electrical. And you say, well, gosh, that seems really convenient. You don't have to have a big old furnace. You don't have to have a boiler even. Everybody already has electrical. You're right. It is really, really convenient. The wires are already there. Well, why don't we just do that all the time? It's expensive. Really, really expensive. Whenever your furnace is on, and no, this is not an exact number, but whenever your furnace or boiler is on, think about you're burning dollar bills because you're spending money when it is on. If it's electrical, you're burning $2 bills. I don't know where anybody even gets them anymore, but you're burning it a lot faster. So you're burning money when those things are on. Electrical is a lot more expensive. So I'd mentioned that some people use in-floor heating for their water. That is kind of awesome because going back to Radiant, you'll recall that Radiant is going to be heating up objects. So if you have Radiant in-floor heating, objects like humans, like your couch, like coffee tables, things like that are going to be warmed up first because they're near where this is happening. A traditional system warms a room from the top down because that warm air rises. Radiant floor heating is heating the objects first. So they kind of do warm up from the bottom up. It's awesome. Still bias alert, my personal favorite. Okay, I hope that you got an idea of the 3 basic types of systems. Tomorrow we will take a look at alternative heating or supplemental heating systems. Till then, have a great day.